to combine it with what 90 Labs is actually doing. So since I work at 90 Labs, I think for me it's the easiest way to just like tell you about all the experience that we did on the way during the 90 Labs journey. And then, yeah, I'm really looking forward to a lot of questions. And also during the presentation, if you have already a question, like just feel free to ask me anytime. And yeah, I'm happy to discuss. So I'm going to start with more like the industrial automation. So at the moment, this is like super trendy in industry. So what you see a lot, or maybe you've also visited a plant, for example, here's a Daimler plant, which shows like this super automated factory where you have those fancy robots that do almost everything for you. And the people that work there, they don't have to do a lot of repetitive work. They can only like do surveillance and do other jobs that are more like fulfilling than assemblies, for example. So at the moment in industry, this is a huge trend that you want to connect everything and that you want to automate everything. So the people have more fulfilled lives during their working time. And what at the moment, what we see, or like what unfortunately is still the reality, is that you have a lot of manual assembly still. So not those fancy production lines from Daimler, for example, which you can go visit, but like really the production lines where you can't go visit. You have like a lot of still manual assembly. So for example, I worked in Daimler and at Rieter, so one company in Winterthur, and Daimler, like the big manufacturing plant in Germany. And there I had to do a lot of manual assembly. And this is actually what drives us at 90 Labs, why we want to change like the way of manufacturing, and also using 3D printing, which I'll get into more detail later. So currently we're a team of 27 people, and our goal is really to reduce this manual work in production, so people can do less repetitive work. Because when you do repetitive work, it gets really boring, and also from an ergonomical aspect of point of view, for example, it's not very good for your health. So yeah, currently we're 27 people. We were founded in 2018. We're a spin-off of ETH Zurich. And yes, so we're still growing. So currently we're moving, unfortunately, out of Technopark into bigger offices to Altstetten, where we have bigger workshops for all our production machines, which I can show you later. And I think these meet the team slide, this already brings me like to the first point, which you probably have heard 100 times. I think one of the main points when you want to scale a company, it's really essential that you have a great team. And for us, so we take the approach that we want to grow inorganic, meaning we know that we can be a market leader in the future. So because there's not a lot of competition in our market, which I'll come to later. So we know we can be the market leader. So our goal is to just grow super fast with money from investors, for example, in order to be quicker than the competition. And having a great team for us, this not only means like the core team, which is the R&D team and the business team. It also means like having great board members and investors. I think this is also like something that is really important, that you, when you choose your board members, for example, for us, it's important to have someone that has already experienced in production lines, for example, that can really help us with those, because like this production field, this is like completely different than everything else. So we have board members that can help us, for example, there. And then the third pillar, which I think from the marketing perspective is really interesting, is like the whole network. At the moment, I think in B2B, you see it, you have like a lot of influencers, you have these technical magazines, you have these different associations, as We Shape Tech, for example, or I'm also super happy that some of the women in 3D printing girls are listening currently. So we have this Women in 3D Printing Association, where you can really benefit from each other without, yeah, also, I mean, without the physical events. I mean, the networking online is also, it's a bit different, but it works really good. And so now you can imagine this industrial automation. There you have a lot of competition. So what we did is like, we did mainly two things. First, we looked at trends, like how does the future will look like. So what we saw is that we have, for example, a lot of electric vehicles will be the future. And for electric vehicles, you need materials that are very lightweight, for example. So because electric vehicle, you want it to go as far as possible. So you need strong batteries for on the one side, and on the other side, you need like really a light vehicle that you can go as far as possible. And another trend that we identified is that these the medical treatments, they get more and more complex. So for example, you have minimal invasive, or you have robotic treatments. And for those two trends, you see that the material requirements increase. And a great material that we work with a lot is carbon fiber composites. So maybe you've heard of it or you've seen it. It's this popular chessboard pattern. For example, a lot of bikes are made out of carbon fiber composites, or a lot of automotive interior, for example. And this carbon fiber composites, they have like great material properties for medtech applications, and also for lightweight structural applications, such as airplanes, for example, or drones. So they're X-ray transparent, they're lightweight, they're biocompatible, and they're very, very strong. And the second, so this is like the trend we identified. So we knew, okay, the things that are coming into market will be, will need new materials. And carbon composites, it's not new at all, but there's a limitation. So the limitation is that for all parts that are made out of carbon composites that are smaller as a shoebox, are still manufactured manually. So you can imagine, you have here, you see this black chessboard pattern again, and people that produce these carbon fiber composites, they really have to manually lay up layer by layer into a mold, and then press it together, and then cut it into the right shape. So this is like very slow in production, and it is very expensive because you have a lot of manual labor that comes with it. And that's where the 3D printing approach comes in from our side. So we thought, okay, we need something for these small parts that currently you make it out of metal. So these small parts, because it's so costly to make it out of composites, people just produce it out of metal. So for example, in an airplane, you see a lot of aluminium parts, which could be made out of composites, but it's just too expensive. So this brings me actually to my second point of how to scale a 3D printing startup. And this is something I heard in a Swisspreneur episode by, now I have to check his name, he's the co-founder of On, Gaspar Capetti, and he told Silvan, like, the market potential for your startup has to be so huge that you don't need a calculator. So you can imagine for us, the market potential, it's not running shoes, but it's like every application smaller than a shoebox, which is made out of metal. So yeah, it can be almost everything. And what we do, or what we developed these last 2 years, is like a automated production line, which allows you to produce these carbon composites on a cost competitive way. So you can be cheaper than, for example, a metal part, which allows our customer then to reduce their production costs, reduce CO2 emissions, and increase the part performance. So this is always like also super important. You always have to understand what your customer needs. I think it's probably more important to understand your customer than to understand your product, or it's equally important. And in the demo, or in the video, I would like to show you later, or next slide, I think, is those things that we developed. So our R&D developed the machines, which consist of a 3D printer and a conventional manufacturing step, which allows production lines to produce those carbon composites in an automated way. And what you see often in industry is, when you have a great machine, it's not enough. You need also the software in order to have the people really use it, because when you just have the machine and they don't know how to use it, it doesn't make any sense. And since our customers, for example, they already use carbon composites, but for hand layup, sometimes they can just use their material they already know and put it in our machine, and then they can produce those carbon composites parts automated. So until now, it's very abstract. So we have these machines, we have this software aspect, and we help our customers to produce lightweight parts. So our R&D did a great job the last 2 years and developed those industrial machines. One is the 3D printer. And I don't know, maybe if you've heard of it, like 3D printing. Often the problem is that 3D printing is only used for prototyping. And prototyping is really nice, and there is like a lot of great 3D printers already in the market that are really focused on prototyping. But what we try to do is really go into this series production. So have a 3D printer that can produce parts for the customers to use it for series production. So for example, to use it for an airplane, or to use it for a lot of medical devices. And I think the easiest way is if I just show you a short video on, it's made in our workshop, like how the machine works. So you have a touch screen, so you can imagine you have the operator that is has an overview on all the processes that are at the moment in production. So you can press print, and then it starts printing. Here, for example, we have this, we call it 90 labs demonstrator. And this is a really nice way of showing the customer that you're not limited to this chessboard pattern anymore, but you can put your fibers. So carbon is like a fiber. It's like a, this is why you always also have this cupboard, this chessboard pattern. And here now, since we have this 3D printing step, we can do it like however we want. So you don't have this chessboard pattern anymore. And now you see that you have like layer by layer your 3D printing, like a conventional 3D printing that you might know from plastics. And when we look like into more technical details, we have one deposition, or like one nozzle where the plastic comes out, and one nozzle where the carbon fiber comes out, because this carbon fiber, they always need plastic around it, otherwise it wouldn't be possible to put it together. And then you can imagine when you print layer by layer, between the layers, it isn't a good, so it's still very critical. So when you try to break it, you can still break it. So the second process step is that you press it together, you apply heat and pressure, and then it kind of melts together. So you get like these structural parts which are almost impossible to break. So this is like a really strong part that is stronger than metal. And you also can see it here a little bit how the structure changes. So it's more flat, and it's really for the end use. All right, and so now, like the most, I think probably the most important thing is when you have this hardware startup, which is based on this inorganic growth, and you want to tackle a market that isn't very experienced with the process, because the process doesn't exist at the moment, because they either produce their metal parts, which they do since forever, or they have this manual hand layups step. So you really have to know what the customer, or how the customer could benefit from your technology. And when you have time and resources available, I think it's really crucial to build these business cases. And so from a software side, I would say it's easier to build business cases. From a hardware side, it's trickier. And there, what we did the last 2 years is like building relationships with our customers or our partners, in order to be able to really produce these business cases, and really have those parts available which you can show to potential customers. And how we approach this is that we just try to have like we have our target markets, which are completely different. So one is the aerospace market, one is luxury and leisure applications, and one is medtech, for example. So completely different markets. And we just try to have for every market a part which we can show. So for example, we start always with this aerospace application, and then people already know, okay, when the product can be, or when the final part is ready for an aerospace application, then it's almost ready for everything, because in aerospace you have the most crazy certification process in order to have your part flying, because when it breaks, it can be really harmful. So there we just try to, in production it's always about cost, so you have to be cost competitive, and this is what we show actually. So we're cost competitive, you can produce at lower cost with our printer. And also the part weight is super important, because at the moment in a lot of companies you have this sustainability roadmap where you want to have less CO2 emissions, and an easy way to start is for an aerospace application. If you just reduce your part weight, then you can reduce a lot of CO2 emissions, because your flying thing is lighter. And then there's another application, for example, in automotive. There we saw, this is actually quite interesting. So first we thought, okay, the automotive market is super interesting for us because there are a lot of parts still out of metal. But in the automotive industry, the production volume is, you can't imagine it. It's like millions of parts, and there our technology is not ready yet to produce 1 million parts. It's ready for like 10,000 a year, but not ready for 1 million. I think there 3D printing is still a little bit behind compared to other conventional manufacturing processes. And the last application which we really like and which we saw is a cool way to get into the market, because medtech and aerospace applications are hard to get in, but when you're in, then you're fine. But the luxury application market, or the luxury market, is quite cool, because they always want to have something new. So every luxury company, for example, in watchmaking industry, they want to be the first that have a 3D printed carbon fiber watch case, for example. So it's really easy to get into this market, but you're also like very soon, you're not trendy anymore, because once someone did one collection with it, it's not very interesting for a competitor, for example, to do it again. Exactly. So I wanted to do a summary slide, but I'm just not a big fan of summary slides, because it always looks like it's just the title and then you have those summary points. So I'm just going to go over the points that I know. I did my notes here. So I think one of the most important things is that you have a great team, and that you really, every person that you hire, that it's really the personal fit is here. And I know it takes a lot of time, and you always have like things that you don't you can't check everything, but I think when you have a great team, this makes it really much more easy. And then having those business cases, I think for a 3D printing company, or every hardware company, it's really essential that you can show something. Because when you can't show something, people always think like, okay, yeah, you're just overselling yourself. So it's really, really crucial, I think, that also that you promise on, or that everything that you promise that you can deliver, and that you're also able to have something in place that you can show. And one thing, yeah, exactly what I did not mention, what is quite cool, or what you see a lot now in industry as well, is that a lot of machines, you don't buy the machines anymore. So our customers don't buy our machines, but they lease it. So from a budgeting point of view of the customer, it's much more easy to get the leasing fee from their boss, for example, instead of buying the machine. So because you don't have to, I'm not sure if this is the right word in English, but you don't have to amortize it over the years, because you have a leasing fee. And if you don't want to have the machine anymore, you can just give it back. And from our side, it's also super cool, because if you have, if you know you have this customer signed for 4 years, for example, you know you have annual recurring revenue, which gives you quite a good feeling also as a machine provider. And one last point that is more on the hardware side is that I think, or what we saw, it is really crucial to have your core competences in-house. So what we do currently is, like, we have a great R&D team, and they really, the first machines that are delivered to the customers, they are really assembled at our place. So our R&D engineers, that are probably the best engineers I know, they really assemble the machines in-house and make sure that when we deliver to customers, they have a machine that works. Similar for the I think software there, people are not, some people say they did everything like not in-house and outsourced the development, but with us as well, we really have the core competences of the software development in-house. So the software was developed in Zurich. It's super expensive, but I think in the long run, it really makes the difference to have these core competences in-house. Yeah, so that was it. So I hope you had an overview of like what 90 Labs is doing and where we really focus on in order to scale fast and in a sustainable manner. And yeah, I'm looking forward to your questions.
Thank you very much. So since we're a few people, like, I would also suggest that those who have questions just turn on the video, or if you don't want to have the video in it, then just tell us or write the questions in the chat, because I saw that there are many people from also the 3D printing area, so I could imagine that they also have questions.
Right.
Yeah.
Hi, my name is Moritz. I'm specifically interested, you mentioned MedTech. I was wondering if you have any collaborations or any partners as of yet, or any projects in that direction.
We have. So the MedTech field is like really, so the NDAs are super strong. So we're not allowed to talk about those projects. But for example, we have like one use case, which is it's called an aiming arm. which is used for when you break or when you have a fracture in your arm. Then you have like the thing that you place into the bone and the thing outside of the body during the operation, so during the surgery. And this thing can be made out of carbon composites. And at the moment, it is made out of carbon composites, but it's milled. So water jetted and milled, which is super expensive, and you have a lot of material waste. And you can't place the fibers where you want them to place them. So this would be something that we can replace in a more cost competitive way. And also, yeah, it's beneficial for everyone, I think. And you can reuse it because it's sterilizable as well. So, yeah.
Cool, thank you.
Any other question? I mean, I can also start with one that I had since the beginning. Like I mentioned at the beginning that you have like a technical background. You did like a mechanical engineering degree at the ETH of Zurich, and I would just be interested to how did that come that you in the first place studied this very exciting field, and then also ended up in a tech startup, but more on the marketing growth side.
Yeah, that's a very good question. So first thing why I ended up in mechanical engineering is, so I was always during my gymnasium time, I was always interested in math and physics. So this was always the courses I liked the most, and I didn't have to do a lot in order to have okay grades. So I was not sure after Matura if I want to study mechanical engineer or more something technical, or medicine. So I decided between those two. And then there was like a day which you could visit University of Zurich and ETH. And so somehow the guy that did the presentation for medicine was, I don't know, he just didn't catch me. And the guy that did the mechanical engineering presentation, this was super great. He had like a lot of applications, for example, medtech applications, or I don't know, everything. And it was so interesting. And I thought, okay, well, that sounds nice. And that's how I ended up there. But it wasn't like, yeah, I just knew that I'm okay in math and physics, and I'll try it. And yeah, and then during my studies, I really liked it. And then I always knew like 100% engineering, it's not my passion. I really like the technical aspects, but it's not something I could do 24/7. So I started during my studies, I did like a lot of tutoring, and also like having the first year students coming to my class to do like, it's called teaching assistant. And there I really started to enjoy breaking down like really complex things into more easy things in order to understand it better. And I think this is also now my main job at 90 Labs. It's just the product is so complex and it has so many aspects, and it's a challenge to break it down super easy to show the benefits to the customer. And I think that's how I ended up here. And yeah, it's really, I think I learn every day new things, because I'm the R&D, I mean, I see what they do, but I'm not super deep in the R&D thing. So always when I talk to the R&D engineers, I'm amazed like what they do. And from the business sides, of course, if you talk to customers, you learn every time you talk to a customer, you learn something new. So this is what really drives me, like this, yeah, always learning something new.
And do you think that you have a different approach to how you handle that? Like you said, you may already in your engineering degree, like you kind of were used to breaking down stuff. Like, is it more that you're a more data-driven marketeer, or do you think it doesn't matter? It's just all this prejudice that one has about engineering or marketing people.
So I'm really, I think I would say I'm really data driven, of course, but since we now have our first customers, there's like, the data is still, how to say, it's not, for us, for example, search engine optimization doesn't make a huge difference for our customer base at the moment. But I think this is something, it's really interesting, and there's like a lot to learn. But at the moment, just for the first year, I think the focus was really on how can we tell a story which is appealing. And I think for next year, when we want to really scale our customer base, then it's essential, and I like it. But maybe there, I think when the team is growing, there will be a good possibility to have someone that can help me out a little bit. Yeah.
So for those of you who are interested, reach out to Tanja.
Yeah.
Do you have any other questions, like from the audience?
So I have a question for you. Can you hear me?
Yeah.
So I actually have two questions. One, you already just mentioned quickly that, like, I was going to ask you what your like next steps and future plans are. Is there anything you can share with us? Any insight for your closer future? And the other question that really is crossing my mind: where do you as an expert and as an insider, where do you see a strong trend going at the moment? What is like the very hot field of 3D printing? Is it the one you are in now, or do you see others, or what interests? Yeah, that would be nice.
Yeah, I think 3D printing, it's like a huge, it's a huge market at the moment. There's like a new buzzword. It's called additive manufacturing 2.0, and it is actually referring to 3D printing for production. And I think this is at the moment a huge trend, because when you can use 3D printing for production, it's just the automation step is, or it helps you automate the whole production line. And also it allows you to really know what is happening in your process. So for example, you have the different printers, and you know exactly how many parts can be produced by those printers, and then you can connect them. You have in the cloud all the data available. You can also, I think one really important aspect is what we also saw with the crisis, that it's important, or that it can be more important for future production lines, that they have their supply chain in-house. So when they have 3D printers, for example, to produce things in-house, it's easier to be prepared for something that you don't know of. Because, for example, when you have a production site in one continent, but you need it in the other continent, it's just when something happens, then it's hard to guarantee the supply chain. So I think there it's a huge trend. And also I think a lot of, in education, for example, you see a lot of courses for small kids that work with 3D printers. Or my colleague just told me that she has her kid, he wants to have a 3D printer for Christmas. So I think it's like really, it's a trend. And your first question, like where are we going, or what is our goal, is so we have, at the moment, it's really the case that for this carbon fiber composites series production, we don't have a lot of competitors. There's like one big competitor, which is in Silicon Valley, and which has like some more financing rounds. They just closed like a 50 million round, and there they have like a different approach. They don't want to have the supply chain in-house. They produce it externally, and I think there we can really add benefit for the customers. So they have a secure supply chain and like a similar technology, let's say. So I think if we can really push this forward, I think it's a good time to be in the market. And like from a personal perspective, regarding marketing or sales team from 90 Labs, we for sure need to have more people, because we see at the moment sales and marketing, it's the limiting factor. We just don't have enough people to deliver to all the potential customers. So there, I think I can say that we'll probably grow. Yeah.
Cool. Thank you for the answer. Lovely.